Hi guys, I'm Anirban from Simplilearn, and today I will be giving you a tutorial on one of the most talked about topics in the world of technology, and that is machine learning. So to start off with, let's have a look at the agenda here. First, we'll look into a life without machine learning. Then we'll move into a life with machine learning. Then we'll try to understand what is machine learning actually. Then we'll look into the types of machine learning. We'll talk about the right machine learning solutions. Then we'll move into the different algorithms that machine learning has. Finally, we'll do a use case wherein we'll be predicting the price of a house using linear regression. Let's talk about a life without machine learning. For someone who doesn't know anything about machine learning or artificial intelligence, he or she might think that it is only being used in robots or machines and stuff, which is actually true as portrayed by most of the sci-fi movies nowadays. But you wouldn't believe how much more machine learning is giving us, how much of it we are using in our daily lives. Let's say you need information on any random topic, say a computer. The first place you would check would definitely be Google, right? It would collect all the information on the word you search for and present it to you according to relevance. If there was no Google, you would have to do it in a very hard way, that is by going through tens or hundreds of books and articles, even after which you won't find the answer. If we go back 4 to 5 years, facial recognition would be a thing only showed in movies like Mission Impossible or Terminator or any of the sci-fi movies you pick. But machine learning has made it possible for Facebook and Instagram to use this feature for your benefits. You don't have to go through the trouble of tagging every single person present in a picture that you have posted. Facebook will automatically recognize the people in the photo and tag them for you. That saves a lot of time for you, doesn't it? Also, Siri, Cortana, Iris, all of them would not be there to help you if there was no machine learning. Now that we know life would be a lot more difficult without machine learning, let's look into the things that are run by machine learning and we are using them on our daily basis. Let's enter the world of gaming. PS4s and Xboxes have introduced virtual reality glasses, which brings a whole new level of detail into gaming. Every time your head moves in real world, it replicates the movement in the virtual world, providing an excellent gaming experience. Then there is gesture control gaming, wherein machine learning tracks your body movement and makes a corresponding movement in the game. Finally, in the game FIFA, your opponent tends to adapt based on the kind of strategy or gameplay you follow. That is again done by machine learning. I'm sure you must have shopped a lot from Amazon. So let's look into some of the places Amazon makes use of machine learning. Let's say you buy a formal t-shirt on Amazon. Now as you buy it, it suggests you formal shoes, ties, blazers and apparels that go with what you have bought. That's the recommendation system powered by machine learning again. The price on every product that you see on Amazon is varying every moment based on demand. That's being done by machine learning algorithms. Then comes customer segmentation. Customer segmentation is one of the most crucial things for all the e-commerce platforms. Machine learning helps them differentiate between customers based on what they buy, how frequent are they, and their reviews. This helps the companies to make sure that their customers are taken care of and their needs are being fulfilled. Now let's talk about an app that you use on a daily basis to reach office on time. Yes, it's Uber Cabs. Once you have traveled with Uber, you must have noticed that it suggests you the places you might want to go based on your previous journeys. When you're taking a share, how does the app make sure that the cab you get is traveled by the same route you want to travel in? There are so many factors like the distance, the traffic, the ratings. All of it is taken care of by machine learning. For the past 5 minutes, we have been talking about how machine learning is improving our lives, where all it is being used. I have probably said machine learning 100 times already. I think it's about time that I tell you what machine learning actually is. Let's take an ordinary system that you currently are using. It can't do much except from the basic operations that you already know about. Now, let's add artificial intelligence, or for a layman's point of view, let's give the same machine the power to think on its own. That is what machine learning basically is. It's an application of artificial intelligence that provides systems the ability to learn on their own and improve from experience without being programmed externally. So if your computer had machine learning, it may be able to play the difficult parts of a game for you or probably solve a complicated mathematical equation for you. that could be really helpful. Let's dive in a little deeper and see how machine learning works. Let's say you provide a system with the input data that carries the photos of various kinds of fruits. Now you want the system to figure out what are the different fruits and group them accordingly. So what the system does, it analyzes the input data. Then it tries to find patterns like shapes, size, and color. Based on these patterns, the system will try to predict the different types of fruit and segregate them. Finally, it keeps track of all such decisions it took in the process to make sure it's learning. The next time you ask the same system to predict and segregate the different types of fruits, it won't have to go through the entire process again. That's how machine learning works. Now let's look into the types of machine learning. Machine learning is primarily of three types. First one is supervised machine learning. As the name suggests, you have to supervise your machine learning while you train it to work on its own. It requires labeled training data. Next up is unsupervised learning, wherein there will be training data but it won't be labeled. Finally, there is reinforcement learning, wherein the system learns on its own. Let's talk about all these types in detail. Let's try to understand how supervised learning works. Look at the pictures very carefully. The monitor depicts the model or the system that we are going to train. This is how the training is done. We provide a data set that contains pictures of a kind of a fruit, say an apple. Then, we provide another data set which lets the model know that these pictures were that of a fruit called apple. This ends the training phase. Now, what we will do is we provide a new set of data which only contains pictures of apple. Now here comes the fun part. The system can actually tell you what fruit it is. And it will remember this and apply this knowledge in future as well. That's how supervised learning works. You are training the model to do a certain kind of an operation on its own. This kind of a model is generally used into filtering spam mails from your email accounts as well. Yes, surprised, aren't you? So let's move on to unsupervised learning now. Let's say we have a data set which is cluttered. In this case, we have a collection of pictures of different fruits. We feed this data to the model and the model analyzes the data to figure out patterns in it. In the end, it categorizes the photos into three types, as you can see in the image, based on their similarities. So, you provide the data to the system and let the system do the rest of the work. Simple, isn't it? This kind of a model is used by Flipkart to figure out the products that are well suited for you. Honestly speaking, this is my favorite type of machine learning out of all the three. And this type has been widely shown in most of the sci-fi movies lately. Let's find out how it works. Imagine a newborn baby. You put a burning candle in front of the baby. The baby does not know that if it touches the flame, its fingers might get burned. So it does that anyway and gets hurt. The next time you put that candle in front of the baby, it will remember what happened the last time and would not repeat what it did. That's exactly how reinforcement learning works. We provide the machine with a data set wherein we ask it to identify a particular kind of a fruit, in this case an apple. So what it does as a response, it tells us that it's a mango. But as we all know, it's a completely wrong answer. So as a feedback, we tell the system that it's wrong, it's not a mango, it's an apple. What it does, it learns from the feedback and keeps that in mind. When the next time when we ask a same question, it gives us the right answer. It is able to tell us that it's actually an apple. That is a reinforced response. So that's how reinforcement learning works. It learns from its mistakes and experiences. This model is used in games like Prince of Persia or Assassin's Creed or FIFA, wherein the level of difficulty increases as you get better with the games. Just to make it more clear for you, let's look at a comparison between supervised and unsupervised learning. Firstly, the data involved in case of supervised learning is labeled. As we mentioned in the examples previously, we provide the system with a photo of an apple and let the system know that this is actually an apple. That is called labeled data. So the system learns from the labeled data and makes future predictions. Now, unsupervised learning does not require any kind of labeled data because its work is to look for patterns in the input data and organize it. The next point is that you get a feedback in case of supervised learning. That is, once you get the output, the system tends to remember that and uses it for the next operation. That does not happen for unsupervised learning. And the last point is that supervised learning is mostly used to predict data, whereas unsupervised learning is used to find out hidden patterns or structures in data. I think this would have made a lot of things clear for you regarding supervised and unsupervised learning. Now, let's talk about a question that everyone needs to answer before building a machine learning model. What kind of a machine learning solution should we use? Yes, you should be very careful with selecting the right kind of solution for your model. Because if you don't, you might end up losing a lot of time, energy, and processing cost. I won't be naming the actual solutions because you guys aren't familiar with them yet. So we will be looking at it based on supervised, unsupervised, and reinforcement learning. So let's look into the factors that might help us select the right kind of machine learning solution. First factor is the problem statement describes the kind of model you will be building, or as the name suggests, it tells you what the problem is. For example, let's say the problem is to predict the future stock market prices. So for anyone who is new to machine learning would have trouble figuring out the right solution. But with time and practice, you will understand that for a problem statement like this, solution based on supervised learning would work the best for obvious reasons. Then comes the size, quality, and nature of the data. If the data is cluttered, you go for unsupervised. If the data is very large and categorical, we normally go for supervised learning solutions. Finally, we choose a solution based on their complexity. As for the problem statement wherein we predict the stock market prices, it can also be solved by using reinforcement learning. But that would be very, very difficult and time consuming, unlike supervised learning. Algorithms are not types of machine learning. In the most simplest language, they are methods of solving a particular problem. So the first kind of method is classification, which falls under supervised learning. Classification is used when the output you are looking for is a yes or a no, or in the form A or B, or true or false. Like if a shopkeeper wants to predict if a particular customer will come back to his shop or not, he will use a classification algorithm. The algorithms that fall under classification are decision tree, naive Bayes, random forest, logistic regression, and KNN. The next kind is regression. This kind of a method is used when the predicted data is numerical in nature. Like if the shopkeeper wants to predict the price of a product based on its demand, it would go for regression. The last method is clustering. Clustering is a kind of unsupervised learning again. It is used when the data needs to be organized. Most of the recommendation systems used by Flipkart, Amazon, etc. make use of clustering. Another major application of it is in search engines. The search engines study your old search history to figure out your preferences and provide you the best search results. One of the algorithms that fall under clustering is k-means. Now that we know the various algorithms, let's look into 4 key algorithms that are used widely. We will understand them with very simple examples. The 4 algorithms that we will try to understand are k-nearest neighbor, linear regression, decision tree, and naive Bayes. Let's start with our first machine learning solution, k-nearest neighbor. K-nearest neighbor is again a kind of a classification algorithm. As you can see on the screen, the similar data points form clusters. The blue one, the red one, and the green one. There are 3 different clusters. Now if we get a new and unknown data point, it is classified based on the cluster closest to it or the most similar to it. K in KNN is the number of nearest neighboring data points we wish to compare the unknown data with. Let's make it clear with an example. Let's say we have 3 clusters in a cost to durability graph. The first cluster is of footballs, the second one is of tennis balls, and the third one is of basketballs. From the graph, we can say that the cost of footballs is high and the durability is less. The cost of tennis balls is very less, but the durability is high. And the cost of basketballs is as high as the durability. Now let's say we have an unknown data point. We have a black spot which can be one kind of the balls, but we don't know what kind it is. So what we'll do, we'll try to classify this using KNN. So if we take k is equal to 5, we draw a circle keeping the unknown data point as the center, and we make sure that we have 5 balls inside that circle. In this case, we have a football, a basketball, and 3 tennis balls. Now, since we have the highest number of tennis balls inside the circle, the classified ball would be a tennis ball. So that's how k-nearest neighbor classification is done. Linear regression is again a type of supervised learning algorithm. This algorithm is used to establish linear relationship between variables, one of which would be dependent and the other one would be independent. Like if we want to predict the weight of a person based on his height, weight would be the dependent variable and height would be independent. Let's have a look at it through an example. Let's say we have a graph here showing a relationship between height and weight of a person. Let's put the y-axis as age and the x-axis as weight. So the green dots are the various data points. These green dots are the data points. And D is the mean squared error, that is the perpendicular distances from the line to the data points are the error values. This error tells us how much the predicted values vary from the original value. Let's ignore this blue line for a while. So let's say if this is our regression line, you can see the distance from all the data points from this line is very high. So if we take this line as a regression line, the error in the prediction will be too high. So in this case, the model will not be able to give us a good prediction. Let's say we draw another regression line here like this. Even in this case, you can see that the perpendicular distance of the data points from the line is very high. So the error value will still come as high as the last one. So this model will also not be able to give us a good prediction. So what to do? So finally, we draw a line which is this blue line. So here we can see that the distance of the data points from the line is very less relative to the other two lines we drew. So the value of D for this line will be very less. So in this case, if we take any value on the x-axis, the corresponding value on the y-axis will be our prediction. And given the fact that the D is very low, our prediction should be good also. This is how regression works. We draw a line, a regression line that is, in such a way that the value of D is the least, eventually giving us good predictions. This algorithm, that is decision tree, is a kind of an algorithm you can very strongly relate to. It uses a kind of a branching method to realize the problem and make decisions based on the conditions. Let's take this graph as an example. Imagine yourself sitting at home getting bored. You feel like going for a swim. What you do is you check if it's sunny outside. So that's your first condition. If the answer to that condition is yes, you go for a swim. If it's not sunny, then the next question you would ask yourself is if it's raining outside. So that's condition number 2. If it's actually raining, you cancel the plan and stay indoors. If it's not raining, then you would probably go outside and have a walk. So that's the final node. That's how decision tree algorithm works. You probably use this every day. It realizes a problem and then takes the decisions based on the answers to every conditions. Naive-Bayes algorithm is mostly used in cases where a prediction needs to be done on a very large dataset. It makes use of conditional probability. Conditional probability is the probability of an event, say A, happening given that another event B has already happened. This algorithm is most commonly used in filtering spam mails in your email account. Let's say you receive a mail. The model goes through your old spam mail records. Then it uses Bayes' theorem to predict if the present mail is a spam mail or not. So PC of A is the probability of event C occurring when A has already occurred. PA of C is the probability of event A occurring when C has already occurred. And PC is the probability of event C occurring, and PA is the probability of event A occurring. Let's try to understand naive-Bayes with a better example. Naive-Bayes can be used to determine on which days to play cricket. Based on the probabilities of a day being rainy, windy or sunny, the model tells us if a match is possible. If we consider all the weather conditions to be event A for us, and the probability of a match being possible event C, so the model applies the probabilities of event A and C into the Bayes theorem and predicts if a game of cricket is possible on a particular day or not. In this case, if the probability of C of A is more than 0.5, we can be able to play a game of cricket. If it's less than 0.5, we won't be able to do that. That's how Bayes algorithm works. Now, we have reached the most important part of our video, the use case, wherein we'll be predicting the price of a house using machine learning. Look at this guy. He seems a bit worried, doesn't he? Let's figure out what the problem here is. So, he's planning on selling his house in a few months, but he's unable to decide what price he should sell it for. So let's help him predict the price of his house using machine learning. So our problem statement is to predict the price of a house using machine learning that will be implemented on Python. Now the first job at hand is to figure out which algorithm to use here. We will be using linear regression for this problem. As I mentioned before, linear regression is a kind of a supervised learning. Let's have a look at the reason why we are choosing linear regression over all the other algorithms. So the first reason here is the output is quantitative in nature and directly proportional to the variables. So I've mentioned this before many times that if the prediction is quantitative in nature, linear regression is the best choice. The next reason is low computation cost. What does it mean? If you use an algorithm that involves a lot of equation solving and stuff, you'll need a very powerful system. So that will cost you more, but not in the case of linear regression because it is a very simple algorithm and it can be done in any normal system. Finally, linear regression is easy to understand, as I mentioned before. Let's have a look at the various features in the dataset. The first feature is the lower status of population in that area. Then comes the mean price of all the houses in that area. Then the building age, the tax rate, the average number of rooms in every houses, the distance to 5 Boston employments, accessibility to highways, and finally the per capita crime rate. So these all are the factors that we'll be taking into consideration to predict the price of a house. Let's move ahead. So let's quickly try to understand how linear regression works. So this is your model, the computer here, and you provide the training data. All the values for the different features you provide the system so that it can learn from it. As you can see, it is trying to study the training data. It learns from it, and then you give it the test data. You give it some values that it needs to predict. Now from the training data that it learned, it will be able to predict the price of the house. That's how the entire model works. It's simple, right? Now that we understand what we are supposed to do, let's implement the entire model on Python. We will be using Jupyter Notebook to run the code. It's because it will be easier for you to understand and I'll be able to explain every line of it to you properly. We'll be using Scikit-learn to load all the data and libraries. Scikit-learn is a library specially dedicated to machine learning in case you are programming on Python. So let's start off by importing the required libraries for the model. So let's import the various libraries from Scikit-learn. Firstly comes up NumPy. NumPy is a support for large arrays and matrices that we are going to use in this use case. Then comes Pandas. Pandas is a package that makes working with relational data easier. Then, from the regression model that we are going to use. To check the accuracy of the model, we import train test split from sklearn.cross validation import train test split. So that's it. All the important libraries have been imported. So let's move on. Now to run the cell, we press Shift plus Enter. So that's it. The cell is running properly. Now from Scikit-learn again, we load the dataset. And to load that, the code is from sklearn.datasets import load Boston. This line is Boston equal to load. So it makes it easier for us to load the entire data set if we want. So again pressing Shift and Enter to run the cell. No errors. So now we'll try to have a look at the data set, Boston. So as you can see, the entire data set is available in front of us. This is the entire data set. This are the values of all the features that we have. These are the names of the features that we talked about before. And these are the target values. With this value, we will compare the predictions that we have. So now we'll divide the data into two different data frames. This is how we create a data frame. dfx. This is one of the data frame equal to pd. So here's where the pandas library come into work. Boston.data columns equal to Boston. Our features, feature names. So the next data frame would be dfy. Data frame Boston.target. So in this data frame, all the target values will be loaded. So that's it. We run the cell 2. That's running fine. Now let's try to describe the data. That is our dfx.describe. Now you can see that this table provides us with the count of every features, the mean value for every feature, and the standard deviation. So all this data can be useful, but not in this case. So let's not waste time here. So next comes an important part. Here we will apply regression now. So the code is reg equal to linear model.linear regression. So that's why we loaded this library in the beginning. We press shift plus enter. The cell is running pretty well, no errors. Now we split our data into train and test data to validate the model. As we move ahead, I will show you how to do it as well. The code is x train, comma x test, comma y train, comma y test equal to train test split dfx comma dfy test size. Test size is equal to 0.2, so that means 20% of the data is test and the remaining is train. 0.2. So random state is needed when we are to run and validate our model multiple times. So in this case we put it is equal to 4. So now what we do is we fit the data set into the regression function. So the code is reg.fit x train y train. Press shift and enter, and now as we can see that our data set is fit into the function that we called before. In line 14 you can see that. So next let's check the coefficient. So the code is reg.coef. So these are the weights and these are optimal. So let me tell you what coefficient actually is. So the coefficients give us an idea of how much the dependent variable will increase if the independent variable value increases by 1. If you take the equation of a line, let's say the regression line, that is y equal to mx plus c. So c is the constant and m is the coefficient in this case. Very simple, okay? Now we will predict the prices. So a will be the predicted price. So a equal to reg.predict x test. So we will be predicting the prices according to arrays. Okay, so a in brackets will specify the array number. So in this case we give 3. As we press enter, we get array equal to 18.15. So For array 3, we are getting 18.1. So if we check on the test data, what is the value for array number 3? This is array number 0. This is 1, 2, 3. For array 3, the test data is 19.3. And we are getting 18.1. So that's the prediction. So you can see that the predicted value and the original value don't vary much. So the predictions are pretty good. So now let's test for array number 5. So in the test table, array 0, 1, 2, 3, 4, 5. So in the test, the value for the fifth array is 24.5 and we are getting 25.4. So the prediction is still pretty good. So our model is functioning pretty well. Now let's try and find the error. So the code will be np.mean in bracket a minus y test. So a is the predicted value and y test is the test value. This gives us the error. Now if we square this value, we get the mean squared error. 2, press shift and enter. So the error value is 25. So that's our mean squared error. So we have successfully created a linear regression model. Now the error value that we got is 25, which is good enough as you have seen in the predictions. It can be made better by manipulating the data as well. Lesser the mean squared error, better the predictions. So let me go through the entire process once more for your convenience. Firstly, we'll be importing the various libraries from scikit-learn. Then we load the Boston dataset from scikit-learn again. Then we transfer the data into two different data frames. So if we describe the Boston dataset, we get a table like this wherein we get the count, mean value and standard deviation for every feature. Then we train the regression model. Next up, we split the data into test and train, wherein the test size is 0.2 and the random state is equal to 4. Then we fit the data into the regression model. After that, we calculate the coefficients and the value of the coefficients you can see on the screen. So then we try to predict the prices. So for array number 2, we get a value 17.5 and for the same array on the test data, it is 17.4. So the difference between the predicted data and the original data is very less. Our model was functioning pretty well. For array number 3, we get 18.1 and on the test data, it is 19.3. So finally, we calculate the mean square error, which came out to be 25.4, which is quite good for our model. So that brings us to the end of the video. I hope you guys understood the concepts. Put your doubts and feedbacks in the comments below and stay tuned for more videos.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.